Okay, we're making this video clip to show the difference between a color camera that can't drop to black and white, a color camera, which is in cell number 2 here, that can go to simple black and white. Then we have camera number 3, which is a megapixel camera that does a true black and white. And the last camera is a regular IP camera, 640 by 480, that does true black and white as well. So you can see the lights are on in this room, and now we're going to turn off the 2 lights in this room to basically put it into darkness. And we're going to see how these cameras respond here to this lighting condition. So our lights are going off, and we can see that, by the way, it's a little bit slower because I'm actually recording this with this laptop. But we see here we have the camera that's non-black and white. This is just a color camera trying to produce an image in this low light scene. So here we have basically our pops and that going through the screen. It's trying to deal with this very low lighting. This camera number 2 is dropped to black and white, but it's done it in a simple black and white mode. So it does not remove the IR cut filter or autofocus itself. And if we look down below here, we have the megapixel camera that does a true black and white and does its auto back focus. And then here we have a regular 640 by 480 that is dropped to black and white and done its auto back focus as well. The 640 by 480 we can see is a better image right now in this low light. That's because it doesn't have to produce as clean of an image because it's not megapixel. So it has less pixels that have to be fed that light. Now, this shows you why if you're not going to introduce an infrared light, sometimes it's better to go with a standard 640 by 480 because it'll give you better low light performance. Once we turn on this infrared light, which is what we're going to do right now, you'll see how the cameras themselves, when they're true black and white cameras, can see infrared light. So our infrared light comes on, and you'll see this is just a little delay. Again, we've got a lot processing through this box right now. So now we see it come through here, and you can see that basically with our infrared light, this is a small infrared light, so it's concentrated right here, but it brings us back the detail that we have in the megapixel camera. So now our megapixel camera can work in that same low light scene. So as we look at low light, we want to remember we have cameras that are basically color. Then we do offer simple black white, which just removes the color in the burst signal from it. Then we have megapixel at night, true black and white, and regular 640 by 480. Each one has its own little detail to it. Of course, when we turn the lights back on in this room, you'll see all of these cameras will automatically come back into their color mode as they recognize that there's enough light in the room. The megapixel comes back, and then the 484 takes about 10 seconds. That's its lowest setting to flip back to a color mode. And you'll see this, if we watch here, it'll flip back to color, and then it's going to autofocus itself and bring itself back into its color mode picture. And there it goes. Saw the IR cut filter go by, and now we have a color mode at that point. So that explains the difference between a regular color, simple black white megapixel, and how it's affected by low light with a true black white, and then our 640 by 480 and how it's affected by black and white as well. True black and white. Thanks.